Okay, let's have a look at these exercises on factorization and exponential growth and decay. Let's warm up with these exercises on factorization first. Basically, the way to do it is to look at each term. So I'm just gonna copy the terms here. So the first term is 3x2y2. The second one is minus 18xy2. If you want to be correct, minus 18xy squared. And then the third term is just a constant, plus 9. So basically, we're going to treat these individually and just have a look at, well, let's start with the numbers. So here we have a 3, here we have a minus 18, here we have a 9. So what's the highest common factor? Well, there's no higher factor than 3 in 3, so that's going to be kind of our upper limit. Let's see if we can find a 3 in minus 18. And of course we do. 3 times minus 6 is minus 18, and then 3 times 3 is 9. So we can write this as 3, and then we have to look at the x's and the y's. Okay, the problem is that we don't have x's or even one x in all the 3 terms, so therefore we can't pull it out from each of these terms. And it's the same thing with y. We have y squared here in both, so that would work fine, but we don't have not even a single y here. So this is the highest common factor. And then we open, let's see, we have a bracket, the open bracket, and then 3 times what is going to be this term? Well, we're missing basically x squared y squared, so that's what we have to fill in here, x squared y squared. Then we have to ask ourselves the question, 3 times what is equal to minus 18xy2? Well, let's fix this constant first. So 3 times what was minus 18? Well, minus 6. Minus 6 times 3 is minus 18. And then we have to write xy squared. And then 3 times what is plus 9? Well, plus 3. 3 times 3 is equal to 9. And we're done. So here, the highest common factor was just a 3. This was A. In B, we have to look at these 2 terms. Here we have a constant, and A and B are the variables. 8, and we have as much as A5 and B to the power of 6. So we can rewrite this as, let's start with the number. So what's the highest common factor in 14 and 8? Well, it's actually just 2, because we can't find a 3 or 4 or higher in both these numbers. So I'm going to write 2. Then we have to look at the a's. We have only one a here, and here we have a to the power of 5. So this is the lowest. This will be the limit for us. So a, only one a, and then we'll look at the b's. We have b to the power of 3, b to the power of 6. This is the kind of the limit when it comes to b's. So we have to write b3. And then open bracket. This means that we're able to find these factors in both terms. So we're able to pull out the 2 from each, 14 and minus 8. We're able to pull out a from both, and we're able to pull out b to the power 3. So 2 times 7 is going to be 14. We already have the a and we already have the b3, so we're done to get the first term. And then minus 4, because 2 times minus 4 is minus 8. And then we already have an a, so we're missing a to the power of 4. And then we already have b to the power of 3. To get b to the power of 6, we have to add another b to the power of 3, and then we close the bracket. When it comes to simplifying the expressions, we just have to x2, y2, basically do the same thing. Look at the constants, the numbers, separately, and then the x's in this case, and then the y's. Remember that this is the same thing as saying 12 times x times y times y over 8 times x times x times x times y times y. And every time we have just a bunch of factors times each other here and down here, we can cross out if they're the same. So when it comes to the number, we can actually find a 4 in both 12 and 8. So if I cross out the 4 in 12, I'm left with 3. I'm going to do this. And down here, if I cross out a 4, well, 2 times 4 is 8, so I'm left with the 2. And then we have x times x, and here x times x times x. So I'm actually going to cross out the x squared and cross out this and write a little 1 in the exponent. So I have 1x left down here. And then we have, well, y squared up here. Sorry, I see that I haven't done a mistake here. It's supposed to be y to the power of 3. Let's see if we can zoom in a little bit. And we see that it's y to the power of 3. So this leaves us with a single y up here in the numerator, y to the power 1, or just y. So 3y over 2x. I can fix this line so it looks a little bit better. In exercise B, we have 27 a to the power 2b over 18 a times square root of b. Well, this requires a little bit of work before we can start to simplify and cross out factors, because we're not really used to this square root of b. So if we write it in exponent form, it's going to look like this: 27a2b. The numerator is the same, and the denominator will be 18a b to the power of a half, or 1 over 2. That's the same thing as square root of b. So remember the rule: when we have bunch of factors here over some other factors here, we can cross out, and we can actually take the exponent up here if they have the same base. So if we look at the a's, we'll look at the 2, and we'll look at, well, we don't write 1 here because a to the power 1 is just a, but it's really a 1 here. So we take 2 minus 1, and the base is going to be written up here. So let's see if we can, let's start with the numbers first, okay? So 2718, well, we can write 27 as 9 times 3 and 18 as 9 times 2. So if we cross out the 9s, we are left with 3, because 3 times 9 is 27. 2 times 9, I'm going to cross out the 9, we're left with a 2. Now, I'm going to write a up here, and then the exponent is going to be 2 minus the 1 down here. So it's a to the power 1 or just a. And then b is actually b to the power 1 here minus b to the power half. So we just take 1 minus a half, which is b to the power of a half. So please note that we write the base up here. When we do this method, we just take this exponent minus this exponent. We're going to write the base up here and the exponent, the new exponent. So in this case, it was 2 minus 1 is 1. Here was actually 1 minus a half, which is a half. And then if we want to, we could rewrite this as 3a square root of b over 2.